think it's still loading.
You see it? Show my screen.
There it goes. We got it.
Hello, everyone. Thanks for joining. Just wanted to kind of tie what you've heard so far with the value of phoenixNAP and Avesha's KubeSlice solution, and kind of give you a visual, right? Of what are the capabilities that come with our enterprise version of the software. So Brad's probably forgot to mention, but we recently open sourced our product. So the core product that drives this innovation is actually an open source product. So you're free. Please, we do encourage all of you to kind of download it, see it for yourself, run it in your own labs, and give us feedback. And more importantly, I think this will be a great project for you to contribute towards as well. So what you're seeing today is more of our enterprise version of the software that comes with this GUI, right? The GUI that's intention is to kind of make it easy for you to operate these slices, right? Kind of bring that value of running Kubernetes services, microservices across the edges, right? This is not a futuristic solution. We know with the deployment of 5G, with the increasing use of edge nodes to bring business value propositions to enterprises as well as telcos, this is a real proposition. It is more of the compute and resources are getting deployed closer to the end users, closer to the business use cases that are being solved. So this is a real problem, right? Being able to deploy services close to the edge, but not only that, make those services available to multiple edges, and also acknowledge that a lot of business use cases are not static cases, meaning the traffic will shift from edge to edge, right? And the KubeSlice from Avesha and the cost reduction that you get from deploying to bare metal, right? The goal is you should be able to run your workloads anywhere where it makes sense, right? Closer to the customer for business cases that need low latency. In bare metal clouds where you have to reduce costs of ownership of running these solutions, right? So this combination and how Avesha Slice kind of enables you to do this with a lot of ease. Right? That was kind of the goal for the UI, is to enable what you can do through APIs on the open source, do it with the self-service nature of the GUI. So we've talked about how you can deploy solutions across clusters, be able to manage it, observe it, and make that operations easy. That's the goal of the product, as well as how do we use multi-tenancy to reduce the cost of ownership for these solutions. So what you see here is an example business use case I kind of created for us to maybe get a feel for what a real use case looks like, right? What we're also seeing is as we engage more customers and MSPs, the power of this KubeSlice is actually opening up new conversations of how do you use the KubeSlice to create business values. And I'm expecting that as you start discovering KubeSlice, you will also probably start these discussions with your customers and find unique ways of bringing value propositions in terms of lowering cost and deploying solutions that are agile, right? They are dynamic, they're orchestratable, and they are automatable, right? That's where the industry is heading, and that's not a nice to have, it's a must have going forward. So what you see here is we basically created two clusters and a management cluster that hosts the control layer of Avesha. And you can see how even though the services are deployed across multiple clusters, you get a single pane of glass, right? That gives you a quick summary of how many clusters are running, how many slices did we create. In this case, the slice represents a tenant, right? And how many nodes are consumed, how many namespaces have been deployed, how many services are running across all of these clusters. So if you look at the logical view of the same thing, pardon the naming, it's not real world, but we have scripts that automate a lot of this stuff. So that's why it shows me, because we need to know it's my clusters that I have to ultimately destroy later, right? So in this case, you see two clusters and a slice for Coke, a slice for HBO, and a slice for Pepsi that was generated. And this is representing three different tenants. And in this one example, Coke and Pepsi happen to have a single application that they are running as part of the service, and HBO has two. So they've basically deployed it in two different namespaces. Right? The same thing, if you start kind of looking at what the slice does, it gives you a very quick visual view of what the KubeSlice is encapsulating, right? It's encapsulating 2 pods. The HBO slice is running an encoder and a sports app, consuming 2 slides, and the Pepsi has got 1 app running on 2 pods. So the UI kind of gives you that operational view, right? Ease of being able to observe your services across multiple clusters. Sometimes it's difficult just to manage one cluster. Imagine the complexity that gets involved when you start deploying these services across multiple clusters. I'm going to jump a little bit into the slice because it ties into, oh, sorry, I didn't expect this to happen. Take a little more of a complex slice. So what the slice is showing is the services for HBO being deployed in 2 of the clusters. And from a service discoverability perspective, it's got 2 of our gateways running on the slice. So something interesting you can notice is from an observability perspective, you can see that the slice is running encoders in both the cluster. They're also running sports data in both the clusters. This is kind of a sample of maybe a redundant system that's set up to, let's say, to create a service that's needed for a period of time where one of the edges is acting as a backup or an active backup. And the traffic can move between these 2 slices, these 2 clusters, but act like it is being serviced as part of a single service. So this one is more from an observability perspective, gives you a single pane of glass that helps you kind of monitor and observe how the slices and the resources are performing. Again, different views of the same thing, your node level visualization of what is running in each of your nodes in the cluster, a service dependency graph. The services that we deployed are fairly simple, so you don't see much of a dependency of one service from the other. But when you deploy applications that have service dependencies, you'll start seeing those graphs here. And from an operational perspective, so typically when you build your infrastructure, you would deploy multiple clusters as part of the service. However, for each tenant, you might or might not include all of the downstream clusters as part of the service. For example, Coke might only want edge clusters in Atlanta, and Pepsi might pick the New York area as where they would focus for some of their services. But as an MSP, as somebody who's offering this as a service, you might have clusters both in Atlanta and New York, but then you might have other clusters that you are building that you might not make it as part of the slice. So what we give you is an easy way to register downstream clusters that you want to partake in a slice with the aim of letting you select for each tenant which slices to operate on. So for example, you can pick the Coke slice and only include in it the clusters in Atlanta. And for Pepsi, you could include only the clusters in New York. And then you can onboard each of these slices to the connected cluster. In this example, I only had 2 clusters, so I essentially added the clusters for all of the tenants, Coke, HBO, and Pepsi. But you can easily envision a use case where some of these tenants might not want to be deployed in multiple clusters. Maybe they only want to be deployed on one, or maybe more than the others, right? So that flexibility of being able to add clusters to a slice at the tip of your fingers, I mean, it's the kind of simplicity and ease that we want to bring to managing services deployed across clusters. I think we also touched on how a slice not only gives you tenancy, but also gives you a way to isolate the traffic between the slices, meaning the traffic of Coke cannot intermingle with the traffic of HBO or Pepsi. Right? The slice, the underlying infrastructure, creates an overlay network. And what that does is also simplifies how you deploy these services across clusters, how it simplifies the IP planning that typically needs to be done when you're deploying applications into multiple clusters. Right? The IP conflict resolution automatically happens with Avesha's KubeSlice. So these are just examples of how we've simplified management of multi-tenant, multi-cluster deployment of services. And it also shows how we've isolated these tenant traffic and resources to give you that true multi-tenancy.
Awesome. Thank you so much, Raj, for showing us everything. Like I mentioned earlier, it's simple, it's easy.